Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about normal distribution. So I hope all of you are doing great. And today, as I said, we'll talk about normal distribution. So I'll share my computer screen with you. Says the time that a randomly selected individual waits for an elevator is normally distributed with a mean of 0.13 and standard deviation equal to 0.289 minute. Part A, find the probability that the person will wait for less than 0.4 minute. So let's do part A. So the picture is like this. The mean is 0.3 and standard deviation is 0.289. And they say, what is the probability that a person will wait for less than 0.4? So if this is 0.4 over here, 0.4, so this is less than 0.4 is this area. Okay. So probability less than 0.x less than 0.4 is I will use my TI-84 calculator. So I will use the normal CDF function, which stands for normal cumulative distribution function. And the lower boundary, I will start from with a very large negative number, minus 1E99 on the left. So minus 1E99 is my lower. My upper is 0.4. My mean is 0.3. That's my mean. And my standard deviation is 0.289. So this is me sigma. How do I get to normal CDF? So I press the second key, then the verse key, and then I scroll down to normal CDF, which is number 2. And type in the lower upper, the mean and the standard deviation. So I do second button, then verse key, which is in the third row. Then I scroll down to number 2. My lower is minus 1E99. It's always, the calculator is set for the lower as minus 1E99. My upper is below 0.4, so my upper is 0.4, my mean is 0.3, and my standard deviation is 0.289. And then I go down to PEST. When I'm on PEST, I have to hit enter and enter twice. And the answer for P x less than 0.4 is equal to 0.6353. Okay, so that's for part A. Okay, now we will jump to part B. Okay, so let me create some space. Part B says, what is the probability that the mean wait time for a sample of 9 people is less than 0.4 minutes? So what is the probability that the mean wait time? So now we are talking about sampling distribution of the mean. Okay, so part B is sampling distribution of the mean. Distribution of mean of the mean. Sample mean. And by central limit theorem, central limit theorem, mean mu x bar is mean of sampling distribution is equal to mu, in this case equal to 0.3, and sigma x bar, which is the standard deviation of sampling distribution, which is sigma x bar is equal to sigma population standard deviation divided by square root of n. So in our case, sigma is 0.289. That has to be divided by, in calculator, it is secant x squared to get the square root of 9. Or it is 0.289 divided by 3, because square root of 9 is 3. So if I move up a little bit, so sigma x bar is equal to 0.289 divided by 3. And that is 0.0963. Okay, so now if I move up a little bit more, create some space. So this is where people can make mistake by not utilizing the standard deviation of the sampling distribution. Again, the same question as before, but however, now we are interested in probability of the sample mean being less than 0.4. So using our calculator, we will use the normal CDF function -1 E99, 0.4. The mean is still 0.3, but the standard deviation is now 0.0963. So this is lower, this is upper, this is mean, and this is sigma. And that is equal to secant verse 2. Lower and upper remains the same, the mean remains the same, only the standard deviation changes to 0.0963. And then we go down to paste and hit enter and enter twice. And this is 0.8505. So this is totally different from the previous answer, which was 0.6353. Why, you ask? This is the answer because the curve, the normal distribution has become narrower now. The standard deviation is only 1/3 of the previous standard deviation. Okay. So with that background, let's go to part C. So part C says, what is the probability that the mean wait time for a sample of 16 people is less than 0.4? So 16 people. Okay. So part C, n is equal to 16. Again, mu x bar equal to mu equal to same as before, 0.3. However, sigma x bar is now sigma divided by square root of n, which is 0.289 divided by square root of 16, which is 0.289 divided by 4. And that is equal to 0.289 divided by 4 is now 0.07225. So now I want to find what is the probability that the sample mean is less than 0.4. So probability x bar less than 0.4 is normal CDF -1 E99 is my lower, comma, my upper is 0.4 upper, comma, mean is 0.3 mean standard deviation is, however, 0.07225. This is my sigma. And this answer is equal to second verse to normal CDF. Lower is -1, E99, upper is 0.4, mean is 0.3, standard deviation is now 0.07225. And when I go down on pest and hit enter and enter, and the answer is 0.9168. So there is a 91.68% probability that the sample mean of 16 people waiting mean wait time will be less than 0.4. As you notice, this probability for 0.9168 for n equal to 16 is more than the standard deviation, the mean wait time for a sample of 9 people, which was part B. For part B, it was answer 0.8505 for a sample of 9. For a sample of 16, it is 0.9168. And the reason is the standard deviation of the sampling distribution for a sample size of 9 is equal to 0.0963, whereas the standard deviation of the sampling distribution for a sample of size 16 is further smaller. It's 0.07225. So the curve has become much narrower. Hence, we cover a lot of area below 0.4. Okay, for the sample mean to be less than 0.4. I will stop here today. If you have any question, comment, do not hesitate to write me a note. I'll get back to you as soon as possible. If you like this video, please give me an emphatic, please give me a hands up, or strong thumbs up, because I really appreciate that. And if you wanted to ask me a question, instead of hands up, you write me a note. I'll get back to you as soon as possible. Okay. Thanks for watching. And if you like this video, please share with your friends so that you and your friends also can subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll be back next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day. And please do not miss me next time, because I'll be back with another problem and another solution. Check out my channel. Do not forget to subscribe to my channel. My channel has all kinds of math problems solved out just for you so that you become the best in math. Thanks again. Take care. Have a nice day. See you next time.